Hi guys, welcome back. In this video, I'll be explaining some of the terms we use in a set. In the last video, I described what set is. I said set is a collection of well-defined objects or numbers that can be distinguished from one another. And I told you that the object I'm referring to can be anything. You can have your object as people, you can have it as a number, and so on and so forth. If that is cleared, I also explained what is an element. I said an element is a member of a set. So remember I told you that you can denote your set with an uppercase letter and maybe your element as a lowercase letter. So A, B, C here, they are element of what? They are element of set A. And in fact, I even told you that you can write your element using this word symbol. In essence, you can say A, B, C are element of A. And if you want to say, describe something as not an element of a set, you can just use this and put, a strike over it like this. It's not an element of A. I told you a set is enclosed within braces, and I gave you many ways you can describe your set. For example, in tabular form, you can describe it algebraically, so using a set builder notation. So you can use word as well. Likewise, I described some of the types of sets, so like finite sets, infinite sets, empty set, and singleton set. And I gave you the difference between empty and singleton set. When it says an empty set is an element with no element, not zero element. If you say zero element, then you are referring to something of this nature, which is describing what we know now as what? Singleton set. I describe subset as well as power set. So today I will start with terms using set. The first term I'm going to describe today is what we know as the cardinality of a set. Cardinality. I briefly described it in the last video when we say cardinality of a set. So that is the number of elements or even elements in a set. You understand now? For example, the other time I said my set A is A, B, C, D. So the cardinality of this set A, which is denoted by N of A, when you see N of A is actually referring to the cardinality. You understand now? So your N of A, that is the cardinality of A, is the number of elements in set A. Okay, let us count them. 1, 2, 3, 4. It means your cardinality of set A is equal to 4. You understand now? Okay, now can you now tell me the cardinality of an empty set? If D is an empty set, it means the cardinality is nothing but H, so it's nothing but 0. So in that sense, cardinality is what? Is the number of elements in a set. Another type I'm going to describe today is universal set. I think I briefly described that as well when I was describing, where you can use to describe sets. I describe it in Venn diagram that your universal set, you can use what we know as rectangle to describe it. So when you now have a set, you can see from the word universe. When you say universe, that is the whole world. So in essence, universal set is a set containing all the elements under consideration. A set containing all the elements under consideration. In essence, okay, before I start that, it is denoted by this. You can denote your universal set as this or this. You understand now? So, in essence, when you have a set, then a set A, for example, a set A will be a subset of the universal set. I describe a subset for you. That when you say something is a subset, that is every element of that set is another set. So in essence, If I have my universe set to be 1, 2, 3, 4, you understand now? Then if you have your A to be 2, 3, and you have your B to be 3, 4, so then your universe, you can say your A is a subset of B, sorry, A is a subset of the universe set. Likewise, B is also what? A subset of the universe set. So then we can conclude adequately that our universe set is what? Is a superset based on the time I described on subset and superset. So in essence, a set containing all the elements under consideration is known as the universe set. And like I've explained the other time, you can use, a Venn diagram to what? To describe a set, a universe set. When you want to use your Venn diagram, then a universe set is enclosed within what? A rectangle. So this actually, describing what we know as a universe set. And don't forget, your sets can be denoted using what? Be described using a circle. So using a circle, since we're talking about two sets here, which is A, B, then you can just put your A here, you can put your B here, and since your A is what? 2, 3, 2, 3, then your B is 4. You can see that when you check all this region, very well, then you can see that A has how many elements? 2 and 3, which is described here. Then B has how many elements? 3 and 4. So if you check them together, all the elements under this rectangle, which is your universe set, are what? 2, 3, 4. So which is describing our universe set. The remaining one can either be here, since we do not have any information describing that. So that's the universe set. If that is clear, let me move to another terms we use. So it is not type actually. So we have equivalent set. You get the meaning of the word from the word itself. It's just like one of my teacher, you will say, okay, now what's the meaning of bathroom? You know that the meaning of bath, you know what it means to take bath. So then when we say bathroom is what? Where we take the bath. So what is equivalent set? When you say something is equivalent set, it's not the same thing as equal set. I'm going to describe that, please. Equivalent sets, when you have two sets are said to be equivalent if they have what? Equal numbers of elements. It is denoted by this. Remember, equivalent is denoted by this. Then you say A is equivalent to B. That is two sets. A and B are equivalent if what? If they have equal number of elements. You understand now? So in essence, their cardinality is the same. So that's what they are trying to say now. That is, when the cardinality of A is also the same thing as cardinality of B, then you say these two sets are equivalent. Let me give you an example to back it up. Let's say, for example, if I have that my A is equal to what? If my A is equal to 1, 2, 3, and you have your B to be A, B, C, are these two sets equivalent? Yes, they are equivalent. Because if you count the number of elements in set A, we have n of A to be what? To be 3. Likewise, n of B is also what? 3. So since they have the same cardinality, that is, the number of elements in A is also the same thing as number of elements in B, then you can conclude adequately that A is what? Is equivalent to B. You can conclude that A is equivalent to B. Let me give you another example to back it up. Example, state whether the following sets is equivalent, are equivalent. Don't forget, by the definition, two sets are said to be equivalent when they have the same cardinality. That is, the number of one set is equal to what? The number of the other set. Okay, now what are the sets? The first one is described as a set builder notation algebraically. That is a set V, which is S, such that S is what? Is a 4Ls. Is a 4Ls. And then you have a set N, which is 1, 2, 3, 4, 5. You understand now? It's not difficult to do at all. So solution, you know your V. If you want to write your V in tabular form, what will be the element of V? A vowel. You know there are A, B, C, D, E. Then your N is what? 1, 2, 3, 4, 5. So if you want to show their equivalency, just find the cardinality of V. What is cardinality of V? How many elements? 1, 2, 3, 4, 5. Then you have 5 here. Then how many elements do we have here? The cardinality of N is also what? 5. So since, you now say since the cardinality of V is equal to what? The cardinality of N, because they are both 5, hence V is equivalent to N. So that's how you are going to be proving the equivalency. Okay, if that is clear, let me give you another term we use. Equality of a set. That's why I said you have to be careful. So equality of a set is different from equivalent set. When you say two sets are equivalent, that is their cardinality are equal. But when you say equal set, two sets A and B are said to be equal. Two sets A and B are said to be equal. Mathematically, you can write them as A equals to B. Remember, if I write A like this, that's equivalency. That's talking about the cardinality. So two sets A and B are said to be equal if A is a subset of B and B is also a subset of A. You understand now? So if A is a subset of B and B is also what? A subset of A. That is, if elements in A are in B and elements in B are also in A. That is, they are having the same element. You understand now? They are having the same element. For example, if I have A to be 1, 2, 3, then your B is also 2, 1, 3. Remember, the order of writing an element in a set is immaterial. Then you can say what? These sets are equal because what? You can see A is a subset of B. All the elements in A are in B, and all the elements in B are also in what? They are also in A. So you can see it is very different from equivalency. So when you are talking about the equivalent of two sets, although these two sets are also equivalent because they are having the same cardinality, but for an equal set, then we are talking about the properties of what? Of the element inside that set. In essence, all equal sets are equivalent, but but all equal sets are not necessarily equal. You understand now? Okay, look at this example now. In A, B, C, D, E, and N, right? V and N. V is equivalent to N. But is V equal to N? V is not equal to N. You understand now? They are equivalent, but they are not equal. Because we want to check the equality, then we have to check the element in each of the sets, whether they are having the same what? They are having the same element. I hope you understand. Let me give you an example to make it more clearer. Example. Determine whether the following are equal or not. Number one, I have A to be 1, 2, 3, and B is equal to what? 1A3. Are they equal? They are not equal, although they are equivalent, because if you check A, is A a subset of B? No, because this is 2, which is not an element of what? Which is not an element of B. So that's equality of a set. So that's that. Another terms I'm going to describe is union and intersection. It's not difficult as well. Union and intersection. Let me take union first. When you say union of sets, so union of sets A and B, which is denoted by this. You can denote union as this is your union, cup, like a cup like. You understand now? So the union of A and B, which is noted by A, U, B, A cup B, is a set containing the elements in A or B or both A and B. That is, when you have a set, two sets, and you want to describe another set, which is A union B like this. So then it is what? It's a set S such that S is an element in A or S is an element in B. That's how you can write it algebraically. When you get to higher level, this is how you are going to write it. Or S is what? In A and B. You understand that? So, and S is in A, or S is in A and B. Let me give you an example to back it up. So let's say my A is equal to A, B, C, D, and my B is equal to B, D, E, F. Okay? Don't forget your A union B, U from this U. If you recall U, so then it means union. That is the combination of elements in A. Okay, what are the elements in A? A, B, C, D. An element in B, taking into account that if you have the same element in A before, you don't need to include it again. You know, for example, now A, B, C, D here is here, but B is in A before, you don't need to write it again. Then you have D, you understand now, which is also there again, E, F. You understand now? So you can see that A, B, we're supposed to write A, B, C, D, B, D, E, F, but you avoid repetition in a set because B, I mean, an element in a set is unique. You understand now? So when you have this type of set, then we call it the union of a set. That is element in A or B or both. So element in A or B or both. So okay, now if I want to describe this using the Venn diagram, like I've said the other time, you know, this is my A. It means I have two sets, and this is my B. You understand now? So then how do you describe that? So then you have your A here. What are the elements in A? But you have to take into account the both, B and D are common to both. Then you put it here, B, D. Then I'm going to have what? A, C, E, F. You understand now? E, F. So these elements are what? We call them A union B. So they are called A union B. That is element in A or B or what? Or both. Okay, now what of intersection? Intersection, on the other hand, that is an intersection of a set which is denoted by this. You know, I said union is denoted by U, cup, but intersection is like cap. When you recall N, that is intersection, U, union. Don't forget. So when you say A intersection B, that is the set containing element common to what? Common to A and B. You understand now? So element common to A and B. So just that maybe you are two friends and you wear your dress and you are using the same cap. That is the intersection between two of you is what is the cap. If the cap are the same, you understand? So what I'm trying to say in essence that if I use the example I used before, which is A, B, C, D, right? So then my B, I said it is what? What is element B? B, D, E, F. B, D, E, F. So then your intersection, which is denoted by this, so is the what? They are the elements common to A and B. What are the elements common to A and B? B is here, A is here, A is not here, you are not going to write it. B is here, B is here, you write it. C is not here, you can see that D is here, D is also here. So that is when you have the collection of elements common to A and B, then you have intersection of a set. And algebraically, you can also describe it as what? Your A intersection B is a set X such that S is an element of A, and you have to note that and S an element of B. You know, if you say or is different from and is what? That is, they have both, they have things in common. You understand that? So they have things in common. So if that is cleared, if union and intersection is cleared, another term I'm going to describe is what? Disjoint set. Don't forget with what I said, that is, you get the meaning of the word from the word itself. What's the meaning of disjoint? That is to join. You know, the prefix this means will mean the opposite. Disjoint means that is, they don't join together. They don't have things in common. You understand now? So that is two sets A and B are said to be disjointed. Are said to be disjointed if they have no what? If they have no common element. You understand that? If they have no common element. In essence, their intersection is going to give you what? An empty set. So these are the rules you have to take into account. So for example, now if I have A now, 1, 2, 3, you can see it is very simple to check A, B, C. You can see these two sets are equivalent. You understand now? But do they have the same thing in common? No. So in essence, your A intersection B, which is describing the common element of both of them, so will now be what? Will now be empty set, file or this. You understand now? So it means when I have P intersection Q and I say my P intersection Q is an empty set, what am I describing? So the information between the two sets is that they don't have anything in what? They don't have anything in common. They don't have anything in common. I hope you understand now. So then the difference, before I move to difference, let me describe the complement of a set. It's another term we use, complement of a set. You understand now? What is a complement of a set? When we say complement of a set, so that is the member in the universe set that are not in the set A. So, but before I go, I think I forgot to describe this. If you want to describe this, using Venn diagram, it means your A intersection B is what? What is common? You can see B and D are common to both of them. You understand now? B and D are common to both of them. So, like I've said, the complement of a set denoted by this. You can use A prime or A raised power C. You understand now? So they are the what? They constitute the element in what? In the universe set, which is the collection of all the sets under consideration that are not in A. That are not in A. You understand now? So that are not in A. For example, if you have your universe set to be 1, 2, 3, 4, and your A is 2, 3. Then the cardinality of A, which is denoted by A prime or AC, they are what? Elements in A. What are the elements in the universe set that are not in A? You can see 2, 3, they are both in the universe set. Then what are those in the universe set that are not in A? So that's 1, 4. So they are the complement of what? The complement of A. Then what can you now say about the intersection of A and its complement? You understand now? So what can you say about the intersection of A and its complement? That will give you an empty set. You understand? Because they won't have anything in common. Okay, now what can you also say about the union of A and its what? And its cardinality. That's going to give you, a universal set. That's going to give you a universal set. In essence, a set and its complement are disjoint. Is it not true? It is very true because they don't have anything in common. Before they don't have anything in common. So, but before I end this video, I think we have some rules joining, the union of a set as well as the what? As the intersection, even the complement together. You understand? But before I proceed, we have something. Uh, Before I describe the term, let me give you an example to back it up. Example, let's say I have my A to be 1, 2, 5, 7. This is a Y question. And my B is equal to 1, 3, 6, 7. So they are the subsets of the universe set. They are the subsets of the universe set 1, 2, 3, 4, 5, up to 10. This means up to 10. They are the set of this universe set, which goes from 1 to 10. Then the question says find number 1, A complement. What is A complement? So then B, A intersection B complement, C, A union B complement. You understand now? Then the subset of B of which has 3 elements. The subset of B, each of what? The subset of B, each of which has 3 elements. Has 3 elements. So I'm going to use this example to give you some of what? Some of the properties we have in sets, which is also true for some of our algebra. So this is not difficult to do. You have your A to be 1, 2, 5, 7. B is 1, 3, 6, 7. So, and your universe set is 1 up to what? Up to 10. Without wasting much of our time, what will be our A complement? Don't forget, complement is the elements in the universe set that are not in A. What are those elements in our universe set that is a set that contain number between 1 and 10, but not in A? What are they? 3, 1. 1 is there, you understand, but 3 is not there. 3 is not in A. 4 is not in A. 6 is not in A. We are considering this, right? So 7 is there. You won't write it. 8, 9. That is the set in the universe set that are not in this A. You know, the universe set are 1, 2 up to 10. What are those sets not there? If you take them one by one, then there are 3, 4, 6, 8, 9. I hope we've written on. Okay, now, so, okay, don't worry. I want to show you something. But although they don't ask us to find B complement, but so that you can understand what B complement means. So what will be my B complement? Yeah, that is 2, 4, 5, 8, 9, 10. That is the element in what? In the universe set that are not in B. Okay, now, then the question asks us to find A intersection B complement. A intersection B complement, right? But you cannot find A intersection B complement unless you know what A intersection B is. So, okay, now what will now be your A intersection B? A intersection B. What are the common elements to both sets? I think it is 1 and 7 only. 1, 7, this is it. You can see now 1 is here, 1 is here. So 1 is here, 1 is also here. You understand now? So 1, 7. Then it means my A intersection B complement, that is the element in the universe set which ranges from 1 to 10 that are not in A intersection B. What are they? That's 2, 3, 4, 5, 6, 8, 9, 10. You understand now? Okay, now let us find, and the third example, the third question asks us to find what? Number 3, A union B complement. Before we find that, you must what? Obtain your what? Your A union B first. What are A union B? Elements in A or B or both. That should be 1, 1, 2, 3, 5, 6, 7, right? Because 1, 2, 3, 5, 6, 7. Let us check it very well. The element in A or B, 1, 2, yes, 5, but 3 is in B. You write it there, 3, 5, 6, 7. Yeah, I think we are correct. Then your A union B complement, that is the element in what? In the universal set that are not in this set. What are they? That's 4, right? 8, 9, 10. 4, 8, 9, 10. So that is that. And the last question asks us to find what? So what is the last question? So the subset of B, each of which has what? 3 elements. Yeah, I described that in when I describe you subset for you. So we have 1, 3, 6, 7. It's just that when you want to list all the elements, you can list the element 0, which is the singleton set, right? You can list that of 1, 1, 3, 6, 7. But the one we are asked to find now are not the what? The cardinality 0, 1, and 4, but that of what? That of 3. You understand now? The one having 3 elements. Then that's going to be what? I can have one, I can have 1, 3, 6. Is that a lie? You understand now? So then I can have 1, 3, 7 that are 3. Yeah. Then I can still have 1, 6, 7 because I've married 1 with 3 and 7, 1 with 3 and 6, 1 with 3 and 7. Then you can have 1, 6, 7. I think you've married everything with 1. Okay. Take the second one too. So then you have 3, 6, 7. I think that's that. You can have 1, 3, 6, 1, 3, 7. So 1, 3, 6, 1, 3, 7, 1, 6, 7, 3, 6, 7. You understand now? 3, 6, 7. That's just that. So these are that. But if you check this very well, you will see that my A union B complement. I want to show you something there. What is your A union B complement? We have 4, 8, 9, 10. There are 4, 8, 9, 10. Likewise, your A intersection B complement. What is your A intersection B complement? That is what? 2, 3, 4, 5, 6, 8, 9, 10. 2, 3, 4, 5, 6, 8, 9, 10. Right? Let me check again. 2, 3, 4, 5, 6, 8, 9, 10. Yes. Okay, now look up. When I find my A complement intersection B complement, although they don't ask us to find it, but let us check because we finished our question here. But I want to derive a property for you here. A intersection B complement, A complement intersection B complement. What are those things they have in common? 4, 4, right? 8, 8, 9, 9. So that is 4, 8, 9. So yeah, I think 10 is here. Then it means we make a mistake for A. Yeah. So I think 10 should be here. For my A complement, that means I make a mistake 10. Yeah. Then if that is true, then when I was finding their A intersection B, that means I made a mistake. So then this will be 10. That will also be 4, 8, 9, 10. You can see they are equal. You understand now? Okay, now let us find A complement union B complement too. What will be their union? This is A complement, this is B complement. Their union will be 2, 3, 4, 5, 6, 8, 9, 10, right? 2, 3, 4, which is the same thing as this. 2, 3, 4, 5, 6, 8, 9, 10. You understand now? So what can you deduce? You will see that these two guys are equal. Likewise, this guy, that is your A union B complement, the same thing as A complement intersection B complement. Then your A complement, A intersection B complement is also the same thing as what? A complement union B complement. So this is known as what? De Morgan's law. We call this De Morgan's law. So De Morgan's law is, or De Morgan's theorem in some textbook, is showing the relationship between the what? The union, intersection, and the complement. That is, when you have the complement of the union of two sets, then the same thing as what? Eh? The intersection of their complement. Likewise, we are having, the complement of the intersection of two sets, then the same thing as what? The union of their complement. So that's what it's saying. That's one of the properties I want to describe. So then another thing is that another property I want to describe here, which you must take note, properties, they are the properties in what? In union and intersection, is that the union and the intersection of two sets are commutative. You understand now? Commutativity law. Commutativity. Commutativity says that your A union B is also the same thing as B union A. I hope you know the meaning of commutative. That is when you change the order of an element and what you have is the same, because your union is also an operator. For example, when you have 2 plus 3, you know addition is operator and addition is commutative, because 2 plus 3 is 5. It's also the same thing as 3 plus 2, which is also 5. You understand now? So this union is the same thing as plus here. Likewise, intersection is also commutative. A intersection B is the same thing as B intersection A. It's also the same thing as B, because multiplication is also commutative. So 2 times 3 is equal to 6, and 3 times 2 is also what? It's also 6. So it's also 6. So if that is cleared, so then another law we have is associativity, associative property. And what is associative saying? That is when you have three what? Three sets. Then A union B union C is the same thing as what? A union B union C. They are associative. You understand now? And what you can, when you have one, you can say 1 plus, you see that 1 plus 2, because addition is also what? So it's the same thing as what? 1 plus 2 plus 3. Just see your union as addition. It is true. Likewise, your A intersection B intersection C is also the same thing as what? A intersection B intersection C. So in that sense, you see your what? You see your multiplication as your intersection as multiplication. Distributive property is also one of the properties of union and intersection. In essence, your A union B intersection C is the same thing as what? A union B intersection what? A union C. Then you say, union is what? Is distributive over intersection. Likewise, your intersection is also distributive over union. When you have A intersection B union C, that's also the same thing as what? A intersection B union A intersection C. So that is your union is what? So it's distributive. The intersection is distributive over union. Another law I'm going to tell you is known as absorption law. I think I've said that the other time. So what is absorption? Absorption is that your A intersection A complement, you know I describe it over there. That's going to give you empty. You understand now? So then likewise your A intersection A union B is nothing but A. So it is nothing but what? It is nothing but A. And lastly, which is De Morgan property, which I've described up. Don't forget your De Morgan's law. What is De Morgan's law? So that is when you have A intersection, the intersection, the complement of the intersection of two sets is the same thing as what? The union of their complement. Likewise, the intersection of the union of two sets, same thing as what? The intersection of their complement. The same thing as the intersection of their complement. Okay, but before I end this video, let me describe what difference of a set is. One of the terms we use as well, difference of set. You understand? So what are difference of set? When you say difference of set, so that is the difference of two sets A and B, denoted by A minus B, your usual subtraction. You understand now? So that is A difference B. You can write this as A minus B too. So when you have the difference of A and B, so it is this set of members, that is set of elements which only belong to B but do not belong to what? Which only belong to A but do not belong to B. You understand now? So if you want to write it algebraically, you can say that your A minus B is a set X such that S is in B, S is in A, and S is not in B. Let me give you an example to understand what I'm trying to say. Let's say I have my A to be 2, 4, 6, 8, and your B is equal to 1, 2, 5, 6. 1, 2, 5, 6. You understand? So it means your A minus B, according to the definition, that is A difference B. So that is, the set of member which only belong to A but not belong to B. What are those elements that only belong to A and does not belong to B? Don't mistake it as the complement. What are those? So they are what? I think 4. 4 is here but does not belong to this guy. You understand now? 6, if you want to, don't just compare it. 2 is here. Check if it is in B. It is there. If it is not there, you write it. 4 is here. Is it in B? No. You write it. 6 is here. Is it in B? Yes. You don't write it. 8 is here. Is it in B? No. You write it. Likewise, B minus A. That is what you have in B that are not in A. 1 is here. Is 1 here? No. You write it. 2 is here. 2 is also here. You don't write it. 5 is here. 5 is not here. You write it. 6 is here. 6 is not here. You write it. Can you see that now? Can you see that A minus B is not equal to what? B minus A. That is the difference between what? Two sets are not what? Are not commutative. So if that is cleared, so I encourage you to, like this video, subscribe to my channel if you've not done so. Also share with your colleagues so that they can benefit too. In the next video, I'm going to give you an example that connects all of them together. So I see you in the next video. Thank you.